Okay. Good morning, good evening, everyone.
Good morning.
Welcome. Good morning. Welcome to the 5th of the PAASE for Philippine Innovation Series, the first in October. And I'm Gisela Concepcion, PAASE member and retired professor, PP, and also an executive member of the National Innovation Council. And today, we have a very distinguished speaker who's multi-awarded worldwide. He's a chemist, and well, just yesterday or past 2 days, he's been interviewed by international and local press because of the Nobel Award given to three chemists uh, whose work is also related to his work in the past. So the PAASE for Philippine Innovation Series is conceptualized to try to gather the scientific and engineering community to try to uh, become more familiar with the innovators that we may have in the country uh, and elsewhere in the world who are Filipinos or of Philippine descent. And this is to explore how their technologies, their innovations can be adopted or made useful in the Philippines, possibly by presenting them to commercial investors. So, without much further ado, I'd like to um, give the floor to my co-host, Dr. Alvin Colaba, to introduce our guest speaker today, Dr. Rigoberto Gobet Advincula. Everyone knows whom Alvin is a very famous person, Vice President of the National Academy of Science and Technology, former PASE President, a former NRCP President, and highest ranking faculty of De La Salle University in mechanical engineering. So, Dr. Alvin,
Yes,
will
Giselle.
introduce Gobet. Thank you.
Hi, Giselle, good morning. Again, good morning. I'm still in Taichung now in Taiwan. So good evening to those in the US and other parts of the world. Yes, we have an exemplar in science this morning on our 5th edition of our Fireside Chat series, PAASE for Philippine Innovation. Our distinguished speaker, as mentioned earlier, is no other than Professor Rigoberto, we call him Gobet Advincula. He is a governor's chair professor at the Chemical and Biomolecular Engineering Department at the University of Tennessee, Knoxville, and the Oak Ridge National Laboratory. A fellow of the American Chemical Society, or ACS, and a fellow of its two divisions, the Polymer Division and the PMSE Division, and also a fellow of the Royal Society of Chemistry. He received the Herman Mark Scholar Award in 2013, and in 2018, he was elected as a corresponding member of the National Academy of Science and Technology, Philippines. And he received also the Lifetime Distinguished Accomplishment Award from the University of the Philippines in 2022. A past president of PAASE in 2012, and also a current member of the board of directors. He is a member of the World Economic Forum on Advanced Materials Council. He's an editor-in-chief of the MRS. This is the Materials Resources Society, I think, MRS Communications, and a visiting professor at Waseda University and the Max Planck Institute for Polymers Research. His research is in polymers, nanocomposites, rubber, 3D printing, and biomaterials. With the recent announcement award of the Nobel laureate in chemistry, which is on quantum dots, he has been involved in the past in this area, and I think still is. Again, our speaker today is so passionate in mentoring students and helping other countries in STEM programs. Ladies and gentlemen, my honor and pleasure to introduce Professor Rigoberto Gobet Advincula. Gobet, the floor is yours. Thank you.
Good morning, good afternoon, good evening. I am in the US right now, so it's evening time here, and I would like to thank first Alvin for the generous introduction, and also Giselle for making it possible to have this series and Fabe for doing the logistics and invitation. And of course, all of you. I've been looking at the attendees list. A lot of distinguished friends joining as well, and friends from other universities that I visited, met, and maybe some of my former students are here as well. I did try to spread the word around that I'll be giving a talk on this topic, materials manufacturing and artificial intelligence, to several channels. So we will have a wide range of audience at this hour, and hopefully we'll have enough time to have a discussion, a question and answer with the topics that I hope to stimulate the hour. And so, yeah, like what Alvin mentioned, the recent news about the Nobel Prize winners in chemistry. Although I don't know personally Bowendi and Ekimov and Bruce, their names and their methods and their science is very familiar to me because of the work they've done on quantum dots and nanoparticle research, which I have used in my group for for almost a period of 10 years, heavily in terms of our research area and students that got their degree in my group and have since become leaders in their own field in many publications. So first of all, let me cite this and congratulate these passionate leaders. So for example, some of the work that we published during this period, we centered on using hybrid nanomaterials based on dendrimers and polymers that are grown on surfaces of these quantum dots. These quantum dots can be based on chalcogenides or lead selenides or semiconductor metals. On the other hand, we did a lot of work also on gold nanoparticles. And we used to call the method simply the Bruce method, which made it very easy to reduce gold and produce these nanoparticles. And so as you can see here, we heavily leverage our interest and work on organic synthesis to make core shell cap nanoparticles. And we found very interesting properties in terms of sensors, display applications, and even uses in biomaterials. So for example, you can see here that quantum dots play a very important role in multiplex imaging, labeling, sensing, or therapeutic diagnostics combination, or what we call theranostics. And they emit color very brightly and very sharp so that you can use them as specific biomarkers or high resolution type of imaging, even observing organelles in individual cells or disease diagnosis in tissues. So for example, you can see here, by just tuning the size, you can actually get different emissive properties, not really based on the chemistry, but just the size. So that is a very important innovation at that time, and it still is. On the other hand, many of these applications have made their way into solid-state devices such as photovoltaic devices, dielectric materials, sensors, display devices, and again, their properties that they emit light and they have very high purity and reproducible, scalable, truly makes them a very important material to our society or today. So let me introduce myself more. So other than being involved with PAASE for such a long time, I recently moved from Case Western Reserve University, which again was a successful stint in my career, to Oak Ridge National Lab and University of Tennessee as a governor's chair professor. This was back in 2020. And this is a position, a dual position, where I run a research group of about 12 staff scientists at the Center for Nanophase Material Sciences at Oak Ridge. So actually, this is a picture of my office in the middle, next to the spallation neutron source, where we do a lot of breakthrough research using neutron scattering, whereas I head, or I'm the group leader of the polymer group on the CNMS side. On the other hand, in the Institute for Advanced Materials and Manufacturing at the University of Tennessee, I run a group that is centered on 3D printing and nanomaterials research as well. So yeah, you can say I have two hats or two mistresses or two masters. And it's a lot of work, I can tell you, but it's also rewarding in many respects. And we live now in Knoxville, Tennessee, and during a very busy season with the Volunteers, which is a very strong football and sports team in the US, with the SEC uh, Council, you can see the very orange color or alternating orange color in Tennessee. So I welcome you to visit us if you have a chance to go to Tennessee. Now, my research group, I have reconstituted my research group upon moving to UT with PhD students, postdocs, undergrads. And as you can see here, I still am in the mission of training students, US, Filipino, Korean, and they're all budding scientists, and a number of them have graduated since, and a collage here of the number of our research work that has made into cover pages of journals. And here are some of my students at Case Western Reserve University. So at Oak Ridge, we have the Center for Nanophase Material Sciences. It is a user facility by the Department of Energy, funded by the Office of Science. And among the 7 groups, I run the polymer or macromolecular nanomaterials group. And we're about 12 scientists, staff, and many equipment to do research. Basically, one floor of characterization, synthesis, modeling, simulation, and access to neutrons and the manufacturing demonstration facility at Oak Ridge. So this is my other role during the week, which is running this research group. Now, in terms of research, we do a lot of work these days on 3D printing, and we've been at it since 2014, actually, and we've done many work related to using nanocomposites or different types of elastomers or rubber, many techniques involving melting of polymers called FDM, or photopolymerization using SLA, and we don't have enough time, and I cannot tell you each of these projects, but we've been pretty good at it. In the program, I started it back in 2014. On the other hand, a new initiative that I started at Oak Ridge is the use of autoflow artificial intelligence-driven synthesis based on reaction engineering principles applied to many types of organic synthesis and polymerization. And this means that we do the reaction, instead of doing it in a beaker, we do it in a pipe or a flow condition, which allows us to control the temperature, the pressure, the residence time, the flow rate, which in turn influences the yield, the enantiometric excess, or different types of biases such as molecular weight distribution and so on. And in fact, by using artificial intelligence and machine learning, we're able to optimize the reaction in record time, and also develop many types of analytical techniques that can be a source of new data or structured data that can be mined towards discovery. And so this AI-driven chemistry, processing, and 3D printing is one of the things that I hope to inspire and explain to you why it is so important, even for the Philippines, to get into this area early, okay? So do not be afraid, for some of you, that I'm just going to talk about chemistry. In fact, that is as much chemistry that I'm going to explain to you. Probably the rest is really more of explanations, pictures, concepts, etc. That will help us focus on our theme this day or this series, which is innovation and how we can apply it towards advances and or advancement of our society, science or manufacturing. So really, the bridge between basic science and the market is applied science or engineering, where you focus on optimization, innovation, doing the right performance cost ratio. And that's very important because without funding at this level, you cannot address some of these pressing problems that are found in industry or manufacturing. And not too many scientists, or not all scientists rather, focus in this direction. Some would say that they would focus on getting the next Nobel Prize by developing the science or focusing on science and not much on application. On the other hand, I myself have transitioned from doing more fundamental work in the past into more applied work simply because I like it. And that is academic freedom. Plus, I like working and solving problems related to industry. So here, you can see that what essentially counts is doing things that are relevant to society at the right cost or performance so that somebody eventually will is willing to support it. And in fact, this is my key towards all these companies that I work with, consulted, got funding through the years, simply by asking the right questions at the right time, which is what is your most pressing problem that we can talk and work on. So with that simple question, a lot of the challenges and problems opens up to you as a consultant or to you as a project proposer. So leveraging that ability to scope the problem together with industry is really the key to working with industry. And so some of these companies, and I won't have time to tell which projects, what I did, and what type of work and what type of funding are some of the companies that I've worked with through the years. So my point is, the science of today is the technology of tomorrow. It still holds in that if you do good science, the money follows. I've heard that principle many times or various forms, but simply focusing on technology without doing careful science, or at least knowing the science behind it, is an exercise in trial and error, if not reactive engineering. So if you are a scientist and you like discovery, you like understanding phenomena, you like digging or trying to mine what has already been designed in the past, or intelligently designed, if you want to use that, or nature design or God created design, it's already there. And it is for scientists to discover it, to report it, and eventually somebody will use that and convert it to technology. And that is really what happened to the Nobel Prize winners, science that I just described earlier with quantum dots. They simply did good science, and eventually the applications followed, or somebody saw their applications in medicine, in display technologies, or developed the process to manufacture them. And I remember meeting many people from startup companies, finding ways or focusing ways to scale them up and find new applications. And still that's happening, but that really is the principle of good science leading to good technology. So the title of my talk mentioned about materials. So just to classify materials, you can divide them into metals or metal alloys, polymers or plastics, ceramics or oxides or inorganic materials or refractory materials. So without going into some of these sub-classifications, there you have a range of what we call material science or materials relevant to society. On the other hand, we need not classify them as materials, but we have to go back to the first principles. One is everything you see around you or you don't even see is all governed by the electromagnetic spectrum. Why? This is the frequency or the energy by which matter moves or matter is felt. So for example, what we see, or if you're looking at my face right now in this talk, it's part of the visible spectrum. But what you don't see outside in a sunny day are UV rays or X-rays when you go to have your medical PET scan, or gamma rays when you undergo radiation therapy, or when you cook, it's microwave, or when you communicate, it's radio wave, okay? So all of this is present no matter what, whether we see them or not, they are part of the electromagnetic spectrum. And so this is the reality. We live in an electromagnetic spectrum world or reality. On the other hand, there are many things we don't see that can be observed using different spectroscopy or microscopic probes that are present in nature. And that goes all the way to molecules, biomolecules, polypeptides, all the way to viruses, pathogens, colonies, diatoms, and so on. But there is a reality which is synthetic in the form of manufactured, man-made materials, all the way to the nanoscale. That is why nanoscience or nanotechnologies center in mimicking the order of nature, but also opens up many opportunities for doing science or material. Again, case of point, quantum dots. The quantum dots, the subject of the Chemistry Nobel Prize this year, are basically nanomaterials or nanoparticles that have properties closer or explainable by the particle in a box theory, or by simply looking at the size is translated to different colors or wavelength. So that type of conversion or translation allows us actually to appreciate design and materials, and that eventually leads to good technologies. In fact, a very interesting convergence is that what you find in living systems, or even all the way to the cytoplasmic nuclear system, can be measured, can be actuated, can be mimicked. And that means the semiconductor world and the biological world is not very far from each other. And so this bridge, by using nanotechnology, is becoming common and more being utilized to develop new technologies, okay? So just letting you know that there is really a relationship between nature and the synthetic world. Now, in my own area, we work with polymers, okay? And polymers are large molecules, or what we call macromolecules. And we can put them together based on polymerization of individual monomers into different constitutions, architectures, microstructure, connectivity, molecular weight, and so on. This is really my field in terms of expertise in synthetic chemistry, in that we're able to make these polymers of varying control, topologies, and complexity. And so utilizing this together with other nanomaterials like quantum dots or graphene or carbon nanotubes, and then comparing the ability to order them on surfaces or different types of architecture that can be called polymer brushes or cross-linked gels or Pickering emulsions, really is a rich playground for science, especially in the colloidal phenomena array. Now, going towards nanomaterials that are commercially available, carbon nanotubes, graphene, nanoclay, cellulose nanofibers, dendrimers, many studies again have been done, but suffice it to say, I have capitalized it as a theme in our research, where we use nanomaterials together with plastics, together with polymers, and making what we call nanocomposites, or adding a certain amount or ratio of these nanomaterials in order to strengthen or to improve the properties of the plastic, and then process them with methods like 3D printing. Okay, so where am I leading the discussion? Well, we mentioned earlier that science leads to benefit. I even dare to say science, good, if you do good science, money follows, or follow the money. But in reality, a lot of things are also driven by necessity. And of course, you've heard that necessity is the mother of invention. In fact, fear is a more destructive emotion. It's a more compelling emotion or motivation to do things. So bad times have a scientific value in that these are occasions for a good learner not to miss and convert or translate it into something useful. So let's take Philippine manufacturing. We are at crossroads in that we are a developing, if not industrializing country, but we have a lot of competition in a global world. We are in a competition for resources, for investments, for technology. So my question is, what are the risks that we can face? I can mention about energy as one of the biggest challenges, which is in fact one of the reasons why the peso is going down. We're importing so much oil. We're importing materials that are no longer manufactured in the Philippines. We're basically importing materials that are used for construction and so on. On the other hand, we claim to be a manufacturing hub, but in reality, our local supply chain is poor or poorly integrated into assembly. And so what happens is a lot of our manufacturing is really assembly, or taking things that are manufactured parts or OEMs abroad, shipping it to the Philippines, assembling it, and then shipping it out. That is not manufacturing, that is really assembly. The other thing that we could be at risk is the BPO, or the knowledge-based source business process outsourcing. Even though we are a leader in many English-based type of services, yet we are lagging behind in knowledge-based sources. In fact, even threatened by AI in many ways. So these are opportunities, but these are risks. There are needs, and what are the solutions? So we live in a global economy. That means we are always competing. If not, we are the target of markets. So for example, China is the manufacturing hub of the world. The Philippines is not, and therefore the Philippines is a market, a target for that market. We do not manufacture machines that manufacture machines, which is done a lot in Europe. That means we will import a lot of machines from Europe. What do we have? We have a lot of human resource. We have a lot of talent. And so that becomes our #1 export. So the question really here is, how can we bring more science and technology and discovery methods that may even be unique in the Philippines, and push back that market view to our country, in that we can even export our way out or become a manufacturing hub. But let's face some of the threats. So for example, plastic is something that, again, is a polymer type. It's not the only polymer type, but we find plastics, paints, rubber, textile. These are very important elements in the society, yet it is a big problem in the world, not only the Philippines, but in the world, in that it is a biggest source of pollutant in terms of waste, things that end up in the ocean, becoming microplastics, which is part of our biome right now. And that simply means that as a country, how do we face this threat to the health of the Filipinos? And so looking at plastics these days, there's a lot of movement and technology to instead upcycle rather than just recycle. Upcycling means being able to convert this waste into useful things, not only for energy incineration, which unfortunately we don't do anymore, which is one of the biggest problems in the Philippines, but instead converting waste into useful intermediates, products, or even polymers. And this is a big program, not only in the US, but all over the world, in that we are interested in more bio-based sources or upcycling of plastics. Another big threat is major diseases. And of course, this is part of the human experience and degradation of our bodies, whether it's cardiovascular or infectious diseases, or the need for new types of therapeutic agents for an aging population. Yet, there are many opportunities in biomaterials, bioimaging, drug delivery, artificial organs, lab in a chip, and so on. And again, this is related to developments in quantum dots, in that it has accelerated the way we diagnose diseases. Another threat, you may say, is the lack of oil, the lack of gas or fossil fuel. And we cannot do away with fossil fuel no matter what, because they have the right energy density and convenience. And it's not going to be an electric world. It's a pipe dream. Yet, this is overlooked, or maybe even a geopolitical risk, because we have actually a lot of oil and gas. It's just in a very hotly contested West Philippine Sea. Now, the shale revolution, actually, I know a lot about this after being in Houston as a professor for 10 years. Many of my students actually ended up working for oil and gas companies like Shell, Baker Hughes, Schlumberger, because of shale oil and gas and hydraulic fracturing. And in fact, this development was key towards energy independence in the US for the last 10 years, except for the last few years where we've had an underinvestment of drilling and resource from fossil fuels. But the alternative, of course, is to draw energy from the sun, from the wind, or from the earth. And among this, the geothermal resource is something that's unique in the Philippines. We have a very high energy source from the earth. It's called steam. It's called hot brine. The problem is, and I know this industry because I consulted for EDC, is that this is a very capital intensive and degrading asset, in that if you don't have the best materials or business case to invest on capital, equipment, and transport or storage of steam, you will not make money. In that, you will end up paying a lot just to maintain the asset. And like any other asset, whether it's wind energy or solar cell, it is not a panacea for energy solution. It can be very good for energy distribution, having many islands in the Philippines. On the other hand, they are still degrading assets. So be wary in saying that we all need to convert to energy based on wind and solar cells. It's not enough. In fact, if you want clean energy, it's nuclear energy, but there are risks. At the same time, there are new technologies that are coming out. Now, where are we heading in terms of the future? Everybody talks about Industry 4.0 or Innovation 4.0 or different types of digital economy-based type of directions. True, Industry 4.0 has brought a lot of distribution, blockchain, different types of industrial-based technologies, all the way to artificial intelligence. Yet, it is a tool. It is a direction that the Philippines should adopt wisely and make it Filipino-centric. 3D printing, I'll discuss a little more about it. It's part of the digital economy and innovation, our Industry 4.0. in that compared to traditional manufacturing, 3D printing has released a lot of creativity and supply models for manufacturing that are very specific and helpful to many types of industries. So let's have a little introduction about AI. AI, or artificial intelligence, is a big set of um, algorithms or methods that centers on design, artificial design of intelligence. And this involves data, computation, network, algorithm development, and so on. So AI technologies eventually will augment or help develop new applications in many fields, from healthcare to education to finance, and of course, manufacturing, banking, transportation, and so on. So what exactly is AI? Well, let's start by the big circle. AI is a big circle that enables machines to mimic human behavior. So that's what artificial means. Under artificial intelligence, we have machine learning. It's a subset of AI in which statistical methods or simulation allows one to improve the methods, or with time and with more iteration, the experience, let's say, for optimization. And you may not know it, but machine learning has been around for a while because many people use statistics for their experiments or design of experiments, or sometimes they call it the Taguchi method or the Weibull function, and so on. And it's being used in industry. On the other hand, deep learning is another subset that is part of machine learning. And deep learning or generative learning follows when you want to develop new subsets of machine learning with multi-layers of neural networks. Now, neural networks is a more intricate relationship of different parameters or different designs of connectivity that allows one to generate new knowledge or new types of directions for learning. However, it needs a lot of data. And that's why the hardware or the ability to collect a lot of data has to be planned in order to generate more learning, okay? And so this process optimization means that you have to understand the different factors, not only applying principles like optimization or principal component analysis, but rather trying to develop algorithms and perfecting that algorithm through iteration. So algorithm development, simulation are very important because it allows you to unlock the hidden variables or define the complex relationships. So for example, statistical methods is a start. Principal component analysis allows you to look at weighted variables. But then if you go to more complex relationships that can be developed by neural networks or generative learning, you can stretch some of this knowledge or even create new knowledge. And so being able to simulate or apply mathematical and computational principle allows one to improve or increase that ability to develop and to expand the field, okay? Now, you need a workflow in that any project where you want to insert AI means that you need to start with data, structured data, the better. But then you need to have a workflow where you train the data, use an algorithm, evaluate it, and then iterate it again, again, again. And when you do this, or you have the capacity to build this, you perfect a model which can then be used for specific work of translation. So workflow is very, very important towards leading to a decision-making process. Another is that when you apply AI, other factors may not be evident. So for example, the supply chain, the skill of the worker, the different types of standards that are used. And so we like to talk about digital twins, with multiple hierarchies. So digital twin is an all simulated background or set of parameters by which you can model without doing the physical manufacturing or experiment, allow one to be guided by what has been simulated. So digital twins, let's say in the case of material science, can go from molecular, rather atomistic, molecular, all the way to macroscopic or mechanical or thermomechanical properties. So applying AI, for example, in manufacturing and the supply chain means that other than the product itself or the ability to produce the product with a particular process, you need to map some of the parameters that are not evident. As I said, the supply chain, the skill of the worker, or even disruption that is common in many industries. We see AI in disease diagnosis and treatment. And again, these are advances that will need different types of technologies, from diagnostics to spectroscopic, microscopic labeling, use of mapping of genetics and omics, or accelerating drug discovery beyond the QSAR by developing different types of subsets or constructs, let's say in protein-based drugs, or different types of drugs that can be related to the structural biology, let's say, of a protein, or even the use of different types of biomarkers or visualization, let's say with medical diagnostic methods such as PET scan or MRI, or even IR imaging that allows one to predict degenerative diseases. Okay, so I'm almost done. And as I said, I want to leave more time for questions. I want to focus now on why I keep coming back to the Philippines and why Philippine engagement is very important. Of course, I'm a Filipino by birth. And of course, I love going to the Philippines. And there are many reasons. One is I want to spur our youth, our education system to produce more PhDs, MS students, professionals that are engaged in the sciences, in engineering. Sad to say, for our population, per capita, we are one of the lowest in terms of the number of PhDs and MS. I think we're already behind Vietnam and Thailand in many ways, maybe even Indonesia. But for a country like us with so much promise after World War II, we are really, really behind. And there are many factors, from availability of jobs or opportunities to train, or different types of job description, whether you go to a laboratory, industry, academia. These are challenges that are unique to the Philippines. So we need to face this head on, and I'm trying my best to contribute to this effort. That is why I've had this mission since I became a professor 25 years ago, to invite as many Filipino students and research scholars to work in my lab. Some of them would stay in the US, some of them will come back. It doesn't matter to me. As long as they get into this field, they will contribute, and eventually they might come back to the Philippines. And so this is a legacy that I would like to contribute to our society. So through the years, engaging with the University of the Philippines, at the time with Giselle and with the Institute of Chemistry and different projects I did together with my time at the University of Houston and at Case Western Reserve University. I'm still a board member of PhilDev, and PhilDev has done a lot to not only bring STEM education advances, but also entrepreneurship. And actually, one of my legacies with PhilDev is I brought USAID funding through PhilDev with the IDEA program, close to $2 million. I led the visiting professor technical entrepreneurship program for 3 years, where I placed many professors in various universities. And one of the legacies I've had, and if some of you are doing it or familiar, is the technical entrepreneurship curriculum that came from CHED that required engineering students to take that course. I was the one who developed that curriculum through field dev times. And so partnering, for example, with DOST and other universities, I've trained many students through sandwich programs, visiting scholars who have been trained uniquely, and for example, in the area of 3D printing, heavily partnering with DOST to produce scholars and trained engineers to work in additive manufacturing and material science. And of course, with PAASE, the programs that we've had here and through webinars like this allow one to disseminate some of these initiatives. I like, in turn, bringing my students or US students to the Philippines in order to educate them and spur their interest in contributing or just looking positively at the Philippines and what we have. And so many years I worked with Engineers Without Borders. I helped develop several stints or visits. Here you can see a picture of our visit at UP Mindanao, Ateneo de Davao, and the Philippine Science High School in Davao, and so on. And this is a program where, for example, we focus on additive manufacturing to the schools. Lastly, one of the biggest things that I help the Philippine government is through AMSEN. So this is really a work that I did with DOST and together with then Yusek Guevara and Boy de la Peña, where we helped establish the first and the biggest additive manufacturing center at that time, and maybe still is, in Southeast Asia, second only to Singapore, Syntec or A-Star. And the training of the staff, the machines and the design, everything was done together during this period back in 2018, 2019. And through the pandemic, the building was finished. So if you visit that facility, and I highly encourage you, you can see all the latest and some of the projects that have been done. So for example, this is some of the pictures I have with the Director Fred Lisa and who's the counterpart at ITDI, and some of the machines and programs they have. So in fact, the biggest statue so far, 3D printed statue in the Philippines, is this of the anniversary, I think a year or 2 years ago, of a series that was 3D printed using plastic. This is 10 foot long or high. All the figures you see here are 3D printed, except for the base, which is cement. And a lot of studies were made in order to qualify these materials and see if they can withstand high winds or even disasters such as earthquakes. So 3D printing is here. It's here to stay. We have it in the Philippines. Industry, companies, startup needs to take advantage of this facility. More and more, 3D printing will play a role not only in prototyping, but also in production for aerospace, marine, automotive, medical, consumer, electronics, defense industries. And again, many things in the Philippines are unique. So an entrepreneur or somebody who has a vision to connect 3D printing and the Philippine economy or innovation needs can find this a rich playground, and you have AMSEN as facilities to use. And finally, I'd like to answer why I keep coming back to the Philippines. It's because it's my home, and it's an opportunity for me to give back to the Philippines. So with that, I'd like to thank you, and I'd be happy to spend time with you on questions and answers. Thank you.
Thank you very much, Gobet. you never cease to inspire me. And among our PASA members, I believe you're the one who has walked the talk and given so much to our country at the same time while you're pursuing excellence in your research in the United States. At every post you held, you brought the scientists, including yes scientists, to the Philippines to explore collaboration in UP and other universities. So that's admirable. So before we open the floor to questions, and I'm sure there are many, I think Alvin and I will ask a few questions. And well, in connection with that, I will just have to introduce some of our guests today. As usual, we have our Executive Director of UP-ORNL, because that's so important. The engineering alumni of UP are the ones who are well leaders in industries that are related to your field. But in particular, I would also like to introduce the COO of the Innovation Hub of the National Development Company. His name is Jer Chen. I think it's at another meeting, but his staff is listening to us. And Gobet and I, are going to have a meeting with Mr. Jer Chen when Gobet arrives this coming week. And at this point, I would like to propose or suggest to Jer that perhaps having heard all the potential technologies that the Gobet has to offer, that Jer could come up with a lineup of potential industries or MSMEs that might make use of Gobet's technologies. So in connection with that, on your end, Gobet, could you share with us maybe three you might call low-hanging fruit, if you might be able to describe advanced manufacturing technology that way, low-hanging applications in three areas that you might propose to, industries here. For example, you have been interacting with the Summit Group, and well, it looks like they have finally invested in polymer technology, the nutcracker that should have been established or put up maybe 40 years ago. But now what's the new technology that you can offer them? This is just an example. So perhaps, Gobet, you can tell us what three low-hanging fruit can you offer to our industries in the Philippines to invest in relation to AI-driven advanced manufacturing?
Mhm. Yeah, thank you, Giselle. And so again, questions, comments, you're welcome. But I'm a research person here, and I'll be happy to spill my brains tonight for those of you who asked questions. I see the potential with the local supply chain of plastics produced by JG Summit, which is mainly polyethylene, polypropylene, or other polyolefins, being augmented by natural fibers like abaca or bamboo or other types of harvested agro waste even. And using this combination to prepare composites that will replace the content or imported content in many of the industries. And I say this because although there's a consumer acceptance, it is an industry when developed can bring a lot of employment to many regions of the country. That's one example. The second example I can put is, of course, additive manufacturing. Additive manufacturing is believe it or not, we're still a leader. I just talked to some people in Thailand. They're not even having their center yet, but we were the first, second only to Singapore to establish this. Additive manufacturing can augment many industries, not only for prototyping, but I believe a very important industry is the repair industry or remanufacturing industry. You see many companies in the Philippines hold on to old equipment that lacks parts because they cannot find the original manufacturer or they cannot import them. 3D printing can solve that. They can remanufacture parts to make old machines work. And that is capital that can be unlocked. So somebody who's entrepreneurial ought to do this. And go to hospitals, go to printing presses, go to farms, and see where 3D printing can help make that machine run again. And probably the third technology, which I didn't have much time to talk, is the use of flow chemistry. I am considered one of the leaders there because of the effort I'm doing with using AI. And that's really my introduction of AI as well. In that manufacturing drugs, chemical intermediates, different types of specialty chemicals will help alleviate our importation needs. In fact, it can mitigate the threat we have against China or India in that a lot of our medicines are really imported. Most of our companies, medical companies, are no longer manufacturing in the Philippines. But being able to, let's say, manufacturing using bench scale flow chemistry rather than doing things in a flask, but using AI to improve the yield and to manufacturing in a modular manner is waiting for investment in the Philippines.
Okay.
I
Giselle?
think, Alvin can ask a question,
Yeah.
except that
Yeah.
I have one comment before I pass
Go
it
ahead,
on
go
to
ahead.
Alvin in regard to APIs. So you call them active pharmaceutical ingredients. It's non-existent. Synthesis of APIs in the Philippines is non-existent, Gobet. I don't think anybody ever did that in the Philippines.
Yeah.
And organic synthesis seems to be a real problem because we need anhydrous and oxygen-free conditions, and somehow we cannot get this to work in the lab until now. So even on the bench scale, it cannot be done. So I don't know. It's a real problem, Gobet. Maybe
Well,
you can solve the problem.
Giselle, the flow chemistry is the solution.
All
This is
right. So
this is a closed chemistry.
yes,
In fact, we do anionic polymerization, which is a no-no in hydrous conditions, or a very
all
little
right.
amount of moisture will kill it. But we are able to do it very easily under flow chemistry.
I
So
think it's something that you should work out with the Institute of Chemistry, ASAP. Anyway,
whoever wants to work with me in this area,
yeah,
but
but organic synthesis
many
is
Yeah, many pharmaceutical companies in the US are already using flow chemistry. In fact, robotic-driven flow chemistry. So I don't see why not, why the Philippines should not engage in this. I mean, really, the key is to bring as much technology to the Philippines as fast as we can, or even copy technology. We don't have to reinvent them. We just have to bring them to the Philippines.
And the infrastructure, the facilities, the equipment, they're not too expensive or unaffordable. No.
No, yeah, you
Good.
can. I
That's very
mean,
good.
any of our major companies or conglomerates can buy them. Actually, the problem is more of people, training the right people to run them. That's why
Yes,
whenever I engage things in the Philippines, I don't start with equipment. I start with people. I start
right.
with training people because that's a more sustainable model in any new technology that you bring in.
Thank you, Gobet. I think Alvin would have a couple of questions.
Yeah, just
Alvin?
because I have to leave soon. No, I'll
Mm.
I'll go first. Gobet, you know very well that over 99.5% of our companies are micro and small and medium enterprises. So how do you think AI, for example, could help accelerate the development of many products at this level of industries, micro and small? They don't have even people, much more the equipment. So with AI, what are the practical applications do you think they could capitalize in this technology?
Right, right. So with smaller companies, I would say they should start with machine learning and statistical methods in their practices because they've been around for a long time. Design of experiment, sometimes we call it Taguchi methods, or even simple weighable function in failure analysis. I think small companies who practice this can improve the quality. I mean, we can use Chat GPT to get some quick answers, but practically speaking, for manufacturing or production or even efficiency of their operation, uh, machine learning practices is a good start.
Okay. Al, I think he has raised his hand. Al, do you
Thank
want
you.
to do that?
Very nice presentation, Alvin. I mean, always want to go back to research every time I listen to you. Whenever what you're doing, I want to go back to my nano cellulose research that I'm advising in ETH.
Go back. Sige, tuloy mo.
I just do consulting now. I consulted a group in ETH in Switzerland for their implant for my material. But my question is, here's the lay of the land. We surveyed 500 companies in October, manufacturing. We have a USAID $5 million project that started in August. All industry driven, all industry partners. We have an alliance with Unilab, Western Digital, and Fastech. And what we did was ask them about their current state of manufacturing, their level of advanced manufacturing, and their adoption of the 9 pillars of Industry 4.0, as USAC Pita requested to check as well. And what it came down to, I just presented the results to the group yesterday because we are also trying to capacitate the line workers and operators, is that only 15% of the 230 completed respondents have advanced manufacturing. 15% out of. And most of them are concentrated in region 4A. And the top 4 activities in IR4 are cybersecurity, supply chain, and big data and cloud computing. And sorry to say it, but additive manufacturing, which is another pillar, and IoT are on the bottom of adoption. And it's a conversation that I just had with the DOST folks at TAPI on Monday and also Wednesday, is that how do we increase? I'm with industry now, and for the last 3 years, I've been with them. I was with Alvin in Davao and Coronadal and again the Oro with DTI Rapid program, where we did the same survey, this time focused on agriculture. It's worse, 1% practice industry 4.0 in agriculture in Mindanao. So my biggest problem right now is I saw your AMSEN and I just spoke to it and they're asking me to increase traffic in AMSEN with the people that I've already spoken to and people who have signified intent to at least have some form of advanced manufacturing practice. But what's missing, I mean, you're a piece of the puzzle, Robert. I mean, academe and the government, I mean, Giselle also holds a piece of the puzzle, hopefully, with the NIC and government as well. The industry that I try to get to see a little bit of their intent and their aspirations with this project right now, besides training and capacitating them for advanced manufacturing, is an access point also. But what's missing indeed is the entrepreneur and the risk capital that would actually do the product development and the adoption of the technology and the advice that you're providing. I like your 3 advices, by the way, that you provided to Giselle. I could have not phrased it any better. Those are the low-hanging fruit. But in specifics, is really working almost man-to-man, tao-tao, in terms of basketball, in terms of being able to demonstrate enough models with individual companies in each of the small, medium, and large sectors that benefit. Because right now, I have one sector that adopted advanced manufacturing and lean manufacturing practices, smart manufacturing, and they saved $250 million, increased their efficiency 99%, and their productivity. So those are the kind of value proposition now I'm using to tell everyone to adopt some form of advanced manufacturing. But I think we need that kind of a refined pitch, or especially for AMSEN, in terms of what specifically in the different industries now can they practically utilize and pitch, and also get assistance from DTI to connect it with the markets, obviously.
Right.
So I think it's a whole approach. Again, I work in ecosystems, if you know that, and really I'm completing the ecosystem now in AMSEN. With you, of course, being in front, because you're the pitch man. So, but if you're coming over here, I'll try to see if I can line up some companies. That's not in your space yet.
It's going to be an ongoing proposition, Al, and you hit so many points. But one thing, as I mentioned before, it's trying to make companies realize or ask them the question, what is your major need or problem? Because once they realize either a threat or a lost opportunity, they quickly act, or they can quickly invest or make decisions. So, for example, AMSEN, we have a facility that's world class. The problem is knowledge. The problem maybe is dissemination. In fact, if I have the budget for AMSEN, I would run a TV ad every day about AMSEN. And people will realize the tools that they can access. So, for example, campaigns, case studies, or simply having a budget to within the government, with or without DOST, to propagate all these new tools and access we have will help. The low-hanging fruit that I mentioned earlier, and I think Kokoy also raised his hand, is the replacement and repair industry. That is a real need. In fact, the savings that have been quoted typically with additive manufacturing is that you save 30 to 70% of the cost or time or production. So imagine if you have this ability to produce the part instead of waiting for months and months for the part to arrive, then you can continue your production, whatever that need is that you're missing a part or a tool. 3D printing can digitize that production or manufacturing of that part. And I'm a proponent of tooling, because they are real values. The Philippines need a lot of machines and tools. And if you use 3D printing not to produce the product, but to produce the machine that produces the product, that is the real value of 3D printing. If you realize that augments many cases of capitalization locally, or even saving capital that would have been utilized by importation, we can really spur the industry towards that direction. And so every company has to decide for themselves what is their highest need and how some of these tools you mentioned, beyond AI, whether it's analytics or statistical methods or other types of Industry 4.0 tools, really just making them realize the need and the benefit or the savings is really half of the battle.
Okay, thank you, Gobet. I think Kokoy has his hand raised. And so, Kokoy, your turn.
Hello. Good morning. Good morning, Sir Gobet, Sir Al.
Yeah, Kokoy, we hear you. Yeah.
Can you hear me? Yeah. Thank you for that explanation and for the question as well, Ma'am Giselle and Sir Al. And for me, the low-hanging fruits would be producing of medical parts like prostheses and orthosis. And what else? For medical applications, we can use it for surgical guides and anatomical models. Next week, I will be meeting here in BPSU doctors from a large hospital in Region 3, and we'll try to start our partnership on producing these kinds of devices that could help several thousands or maybe millions of people in the zone. Another application could be coral reef restoration. We can use 3D printing. Sir Gobet, right now we are able to 3D print clay, terracotta clays, and stoneware. So I think that can be a part of projects for a coral reef restoration. I mentioned this to Dr. Concepcion, Ma'am Gisela, and she introduced me to Van Rodriguez of UPMSI. And those are just two things, aside from the first one, spare parts production that Sir Gobet has mentioned. Thank you. Good morning, everyone.
Thank you. Thank you, Gobet and Kokoy. It's now 9:40, so we're down to last few questions. But I think that with Al here, who's a very important part of the puzzle, and Gobet, I think that if we were to identify the low-hanging fruit for certain industries or MSMEs, perhaps a value proposition or a business plan would help, because the businessmen or industries would need to know their initial investment and what the ROI would be. So perhaps Al, you can help identify together with Gobet what might be of interest to big and medium-sized businesses, and well, help come up with a business plan. The other thing that I have gathered is that while the government, the DTI, is always talking about upskilling is confined to the virtual technologies, the IT technologies. So that seems to be the focus, digital technologies. But on the other hand, we have to find a way to get the industries that may have opportunities to grow with 3D printing technology to be trained in the AMSEN facility. So Gobet, perhaps you can convince the DOST to open up the facility for training of industries that would benefit from this technology. So which is what I'm saying, materials technology has to be emphasized. Food, for example, agri-mechanization, agricultural mechanization. We're talking about machines that break down or are not used or just wasted because the farmers and the cooperatives do not know how to use them. Now is the time to try to get them to work. And if they need spare parts, then perhaps you can 3D print the spare parts. So things like this. Anyway, I'm checking for more hands raised. I think Kokoy, aside from you, I don't see any more hands raised.
Yeah, Giselle, I'd like to add two more things. I think,
Yes.
yeah. So other than additive manufacturing or even what I explained earlier with flow chemistry, AI, I think one of the biggest things we need to focus also is helping maintain the lead of the BPO, business process outsourcing industries in the Philippines, because we are under threat or challenge all the time. Some of the reshoring that's occurring, and I don't know, I think this is not really the biggest focus of this talk right now, but I just want to mention too that training or giving tools for the BPO industries to capitalize on AI or learn AI tools or use or go towards more knowledge-based is the armaments industry, the Department of Defense. Branches of the United States military, from Navy, Air Force, additive manufacturing best practices already in their units. So for example, you can have a modular unit that has additive manufacturing to repair or to replace. And we're seeing it also in the Ukraine-Russian war. So I'm just cautioning that the Philippines ought to get into this sooner than later, because it will help the country become more independent when the time comes that we are crunched for supplies.
So you're so right about that, Gobet. We know that Ukraine is using 3D printing for their armaments. That's very true. And again, I'd like to point out that the National Development Company Innovation Hub COO is here, Jer Chen, and is hearing all of this because NDC is a GOCC that is affiliated with the DTI, and it's got a lot of funds that it invests in. Okay, well, for government projects as well as for the private sector. And we are going to meet with Jer Chen when you're here, Gobet. Okay, so is there anything else that we would like to discuss?
I think Val Reyes of Earthfee is raising his hand.
All right, Val. I'm happy to have Val here. So it's your turn, Val.
Good evening, Dr. Gobet. Thank you for your for what you've shared. My question is, there's such a myriad of possibilities on where to apply AI 3D printing. Is it practical to think in terms of one specific initiative where this can be piloted and then use that as a success story to create a ripple effect, if you will? You know, sometimes it's a matter of really overcoming that initial fear or resistance, you know, including the possible concerns about cost and all of that. Is it possible for us to think in terms of a very specific initiative, you know, drill down into something that's a pain point for industry or government?
Yeah, so yeah, thank you, Val, for that question. So I would say each company will have to ask the question, the relevant question. What is your, sabi mo nga, what is your pressure point? What is the bottleneck? What is the biggest threat, or what is the biggest problem that will produce the maximum effect if the right solution is found? So first ask that question, hard question, come up with 1 to 3 types of problems or scenario. And then let's match the AI or the manufacturing that can possibly solve the problem. A lot of this question starts with, you know, if I have this, then I'll get that. If I can get rid of this, I'll get that. Or if I can do this more efficiently, then we can produce this amount of savings. I would say in terms of the AI, let's start with machine learning and statistics. And we do what we call principal component analysis that can easily be done, even as software exists, where we can define variables or functions that are seemingly unrelated, but when solved or used or controlled better, it produces the maximum effect. So let's start with that type of analysis and that problem. And then secondly, we can try to find a ready technology solution that's available already in the Philippines if we can, rather than waiting for the company or an importation protocol to bring it to the Philippines. And that's why AMCEN is so relevant, because when I designed it, I said, let's get the best machines we can on this technology so that it's available for the Filipinos. So in fact, between AMSEN and ITDI and MRI, they have the best materials characterization, fabrication methods. They have the best 3D printers, similar to what you can find in Singapore or in the US. It's just a matter of matching those capabilities in the rapid prototyping or manufacturing method. So for example, the typical savings that can be quoted in many case studies is between 30 to 70% in terms of cost and time. So for example, yung injection molding. An injection molding that uses molds or tools in the plastic industry, they have to be machined, imported from Singapore or even from China. It takes months and very, very expensive to ship them because these are heavy equipment. Imagine if in the Philippines, you can 3D print those molds from a digital design. So instead of buying them, importing them, shipping them, manufacturing them on site saves already on the shipping costs. And then using digital economy or digital manufacturing method means that you can perfect the design right here instead of using the traditional milling method. So those type of examples has to be sorted company for company. And the more case studies that are made on specific classes of the industry, so for example, plastic industry or marine industry or jewelry making industry, the more case studies we have for each of those categories, the more they'll become evident to the rest of the sectors of that industry to use those tools.
Thank you, Dr. Gobet.
You're welcome.
Very well explained, Gobet. I hope Val is satisfied. But I think Aval and Tito, you have a big role to play as well in trying to get the industries that are linked with UT-ORNL to maybe explore how they could risk these investments, these new technologies as investments, and convince them that there are in fact substantial savings by adopting these new technologies. So at this point, I think that we will have to end our fireside chat soon. And Alvin has left for his meeting in Taiwan. I myself I'm in Kuala Lumpur, and I'm attending a conference here, and I have not joined the first talks because of our fireside chat today, which is to me very, very important. So I'd like to thank everyone for joining us, and just know that
I think there's two more hands that are raised. Sean,
my goodness.
Sean Raimundo
All right,
and Cora Claudio.
Oh, Cora was able to come in, and of course, PEAKR. So let's have them please ask their questions quickly, please.
Go ahead,
Okay.
Sean.
Then I have the question. This may be an ignorant question, but I'll ask it anyway. Can there be something from your research results that BPO, specifically the call centers, can apply so that they'll become more efficient and more competitive? I heard that some companies are now transferring their call centers to other countries. Thank you.
I would say one can start with several software that is key towards knowledge base type of service, beyond technical, and that is becoming an expert in some of the tools, let's say from Acrobat, Adobe. There are certain tools from Microsoft, but certainly ChatGPT, just knowing the rudiments about it is a good start. So having a training that can be paid or low cost in this type of modules might be useful for certain sectors. And then, of course, trying to attract or scout for businesses that uses these tools. So the more we engage in this direction, the more we can be prepared for the threat that other countries are doing. And of course, we can look at India or even some countries in Mexico and South America. I mean, Mexico is actually becoming fast a competition between the Philippines. because it's so near the US that in Mexico, they have a very vibrant BPO industry that's blooming.
Thank you.
Okay,
Go
I
back.
think,
Yes.
I think Cora Audio.
Okay, can I just say something? Al, can I
Cora.
just say
Okay.
something? Before I call Cora, I would like to mention something that is related to the BPOs, which is higher value than just a voice, or it's the creative industries. It's a major industry in our country. And the
Mhm.
creative industries is like part of the BPO, animation and all that, that can also benefit from AI. Okay, so that kind of upskilling. Anyway, now
Yes.
let's call Cora. Cora, thank you for joining us. Finally, you were able to get in.
Thank you very
Cora.
I came in late and it hit the 100 participants and could not enter. Okay, we are now waiting for the approval and working hard to have it approved of a new law. It has passed many steps already and we are almost at the end of it. The Philippine PENCAS, Philippine Ecosystem and Natural Capital Accounting. Because one problem that we have in this country is that we really do not look at our natural capital every time we want to do something, right? We have at least 3 crisis areas now that we are looking at. I have a team that is trying to identify what we can do here. I call them few catalysts for development. Few in terms of number and also in terms of food, energy, and water. So let's just focus on energy. We are now trying to get the SMRs, which I think should be called SNRs because we should not forget that that is still nuclear, small ones that can be good distributed energy systems, except that they will also lead to creating distributed radioactive waste. While we have ample supply of natural capital in this area, and I'd like to know from you if, for example, on solar, we know there are many issues there, from land to where we shall place them. There are researches going on outside. Can you suggest a focal point where in the US and in your area of research, you're already seeing advanced developments for solar? Because solar is, we have ample supply of it.
Mhm. Yeah. So yeah, thank you, Cora. So the solar industry really has bloomed because the cost of manufacturing it decreased because of China. And ultimately, a lot of the solar manufacturing leads back to China, whether it's parts or extraction of metals or scalability. And the Philippines cannot compete in the manufacturing of local solar devices again with China. We'll have to import it from China. So that's one thing. Another is land, flat land, available land. The Philippines is largely a mountainous country. I don't know if many people realize that we have more mountains than farmlands. And the flat space is a premium, not only for agriculture, but now solar is competing with agriculture in many ways. Putting it in the lake, some people say it's good, some people say it's really bad idea. I don't know yet, but one thing with solar, it generates a lot of heat. Okay, it still absorbs heat, and also the infrastructure that you need to put it in place. And mind you, disasters or different types of risk comes with damage. So once you damage the asset, to replace it again is an economic cost. So solar will never compete with fossil fuel because the energy density is not there. Plus, we may have sunlight in the morning, but in the evening, there's no solar. And some people say, let's balance it with wind. Yes, you can do that. You can combine solar, wind, and probably you produce some energy, but it's not enough energy to produce many of the things we need. as a developing country. So the answer really is a mix. It's a mixture of everything, anything that makes sense, whether it's solar, whether it's wind, whether it's oil, gas, and certainly nuclear. And you just need to understand the advantage and the risk of each and the economic model. So I would say the Philippines just really have to have massive investments in all forms of energy where it makes sense.
All right. Thank you, Gobet. I think we can have you speak again about the energy issues, but in November, we will have Joey Ocon speak to us about energy and the batteries that he's developing the startup company.
Giselle, are you still on or?
You're muted, Dr. Sella.
I said, thank you for that, Gobet. I said that we can have you again for another session on energy issues. But in November, we will have Joey Ocon of engineering speak to us about his project in a startup to build batteries, but also about it's going to be about his paper on using hybrids of energy sources in different parts of the country. So an analysis that he did with his research group. So I think, Cora, that's a very, very important question. I'd like to introduce Cora to everyone here. She's with the Management Association of the Philippines. She's a social entrepreneur, and she's very concerned about the ecosystem, the marine ecosystem, and about natural capital accounting. And she's a PhD in engineering from Stanford, but also a businesswoman. So thank you, Cora, for joining us. Anyway, at this point, I think we have to call it a day, Gobet. And I'd like to call it a night in your end. And you're traveling soon, and I hope we can get together with Al as well when you're here. You have a very tight schedule. But anyway, we have other speakers of interest. So everyone here to next week, next Friday, it's going to be a duo. It's going to be a Taiwanese lady who's into smart climate resilient agriculture, greenhouse agriculture, partnering with Gawad Kalinga's Mark Lawrence Cruz. So we will tell you about what investment is being made by the Gawad Kalinga in this smart greenhouse technology that is developed in Kaohsiung, Taiwan. And after that, we will have Elmer Dadios of De La Salle talk to us about his robotic machines for agriculture. And in November, we have many other speakers with very exciting innovations to share with you. So with that, I'd like to just call your attention to forms that we have. They're on the website. Form 1 would be an innovation grant proposal, although the final form of this for 2024 is not out yet. But then you can start thinking about, what you'd like to propose as, a project for an innovation, not an R&D, but an innovation grant, really ready for commercialization. Second is if you have any concerns, you have a position paper that you'd like to share, then there you can write a position paper on Philippine S&T innovation. And the third would be barriers to innovation and your proposed solutions. And this would include your first-hand accounts of what the barrier was for you, made it difficult for you to do R&D or to do an innovation project. And let me say that we already launched the NIASD, the National Innovation document last Wednesday. And then road shows will begin in October, November, December in Luzon, Visayas, and Mindanao. And we're also planning innovation competitions that are industry-oriented and social innovation-oriented. Now, these are all plans. Wish us luck that these get approved by the NIC at its next meeting with the president. So everyone, thank you so much for joining us. And please stay tuned every Friday. Make it a habit to join us at PAASE for Philippine Innovation.
Thank you very much, Gobet. Hope to see you again.
Photo ops.
Thank you. Thank you all.
Yeah, I like
Salamat.
Thank
Gobet
you so
because, as you said, he walks the talk. We talked about
Yes.
corrosion in the Philippines. He said, when do you want me to conduct the seminar? And he said, tomorrow. And he was there.
Yeah.
So
Yeah.
he's a man of action. So
Ever
beyond
ready.
all of this research, he is on the ground. And that's the guy I like. Thank you
On
very
the
much.
ground. You're right.
Salamat.
So train so many people. Okay.
Thank you, Gobet.
Spends his own money as well. Anyway, I don't know if you need time for a you would like time for a group photo. Feb, could you take a photo of the group?
Yes po.
Just
Kindly
a quick one. You did already. All right then.
Thank you.
Then thank you so much, everyone. I myself have to go because I have missed the session of my conference.
Sige.
So see you soon, Gobet, and let's hope for the best. Always. Bye-bye. Thank you,
Bye.
everyone.
Bye-bye. God bless.
Bye.
Thank you.
Bye.
Mm.